March 1943, Tunisia. Dawn broke over a wasteland of craters and twisted metal. German bombers had struck again before sunrise, turning the Allied airstrip outside Tebessa into a scorched ruin. Smoke curled from shattered fuel drums, wrecked tents fluttered in the desert wind. But before the fires were out, another sound rose above the silence, a deep mechanical growl. American bulldozers rolled forward, their blades biting into the scorched earth. Within minutes, craters vanished under layers of compacted soil. Trucks dumped gravel, graders leveled the surface, and men in dusty fatigues moved with practiced rhythm. By nightfall, planes would land here again. To the Germans watching from reconnaissance aircraft, it seemed impossible. The same airfield they had destroyed that morning was alive again by evening. That miracle of speed had only just begun. The Allied campaign in North Africa had reached its critical phase. By early 1943, the newly blooded after Kasserine Pass was learning the brutal arithmetic of modern warfare. Aircraft needed airfields, and airfields meant victory. Every day lost to rebuilding a cratered runway meant more convoys sunk, more soldiers stranded without air cover. To sustain the advance across the desert, engineers of the U.S. Army Corps and the Navy's construction battalions, the Seabees, took on a new kind of battle. Their enemy was not the Wehrmacht, but time, terrain, and gravity itself. They moved with columns of Caterpillar tractors, Letourneau scrapers, and Euclid dump trucks, machines that turned raw earth into operational bases faster than the Germans could destroy them. Unlike the Wehrmacht, which relied heavily on manual labor and horse-drawn wagons, the Americans had industrialized motion itself. Each machine was a weapon of logistics, designed for endurance rather than spectacle. Bulldozers carved out runways where none existed, in Tunisia's baked clay, Sicily's limestone hills, and the coral rubble of the Pacific Islands. The Germans built fortresses. The Americans built momentum. Every new strip extended the reach of Allied bombers deeper into Axis territory. From these hastily built fields, B-25 Mitchells and P-40 Warhawks rose daily to strike convoys and supply lines, crippling the Africa Corps, lifeline to Europe. And yet, even as the Allies advanced, German planners remained convinced that such rapid construction was unsustainable, a burst of energy that would soon burn out. They were wrong. Behind every American advance in 1943 stood a quiet revolution in engineering. The U.S. had not only mobilized soldiers, it had mobilized entire industries. From Illinois to California, factories worked around the clock, turning peacetime construction tools into wartime lifelines. Caterpillar's D7 and D8 bulldozers, once used for farming and highway work, were now painted olive drab and shipped by the thousands across oceans. Each machine represented a doctrine: speed over symmetry, practicality over perfection. American engineers didn't wait for ideal conditions. They landed on beaches, cleared mines, leveled ground, and laid metal matting, all under fire. Portable steel mesh, called pierced steel planking (PSP), allowed them to build a 5,000-foot runway in days instead of weeks. The German high command, steeped in rigid doctrine, couldn't comprehend this kind of fluid logistics. Luftwaffe engineers were trained to construct permanent, fortified airfields, deliberate, symmetrical, and slow. Their mindset belonged to the pre-war era of precision engineering, not industrial improvisation. When Luftwaffe reconnaissance units reported destroyed Allied airstrips operational within 24 hours, senior officers dismissed it as propaganda. They didn't understand that bulldozers, scrapers, and motorized graders had become part of the Allied arsenal, as essential as tanks or bombers. The concept of engineering warfare was uniquely American. Build faster than the enemy could react, turn destruction into opportunity, and make the battlefield itself your factory. As the Allies prepared for invasions in Sicily and Italy, airfields were no longer strategic luxuries. They were the arteries of modern war. And soon, those arteries would stretch across continents, carrying the power of American air dominance from the deserts of Africa to the beaches of Europe. For the men who built those airfields, war sounded less like gunfire and more like steel teeth biting earth. They were engineers, surveyors, and heavy equipment operators, soldiers who fought with wrenches, not rifles. Yet they worked closer to danger than many front-line units. In North Africa, construction crews labored under the roar of German Stukas, their shadows sweeping over half-built runways. When bombs fell, they didn't scatter. They waited for the explosions to end, then climbed back onto their machines and kept digging. Every hour mattered. Bulldozers worked in pairs through dust storms and darkness, headlights covered in red filters to avoid detection. Seabees joked that they didn't need sleep, just fuel and cigarettes. Their motto, "We build, we fight," wasn't bravado. It was a statement of survival. At the airstrips near Gela, Sicily, engineers fought both the enemy and the land itself. Mud clogged engines, trucks bogged down in flooded soil, and water had to be pumped out before compaction could begin. But within 72 hours of landing, Allied fighters were taking off from runways that hadn't existed days before. To the German pilots who returned to bomb those sites again, it was demoralizing. They would find new fuel dumps, fresh ammunition stacks, and flattened craters, a living demonstration that America's machines could erase destruction faster than they could inflict it. Letters home from engineers spoke rarely of heroism. They described blisters, engine noise, and the constant ache of exhaustion. Yet there was pride too, the quiet knowledge that every shovel of dirt meant another squadron could fly, another convoy could be saved. For many, the war was measured not in victories or losses, but in yards of runway reclaimed from chaos. To the German High Command, the bulldozer was an afterthought, a construction tool, not a weapon. But to Allied commanders, it was the cornerstone of a new kind of warfare, mobility through engineering. Every time an airfield rose from rubble, it altered the balance of the skies. During the North African campaign, engineers could make a runway operational in under 36 hours, faster than German bombers could plan their next sortie. Luftwaffe attacks aimed to cripple Allied air power, yet each raid only created more work for the bulldozers, not defeat. The secret was systemization. American engineers didn't rebuild blindly. They followed modular blueprints refined in training fields back home. Soil compaction ratios, drainage ditches, gravel layering, every detail was standardized. Bulldozers didn't just dig, they executed a process perfected by civilian industry and adapted to war. The machines themselves were marvels of wartime innovation. The Caterpillar D8, weighing nearly 20 tons, could push 9 cubic yards of earth per pass. Paired with Letourneau scrapers and Alley's Chalmers graders, entire runways took shape like assembly lines. Engineers often said, "The battlefield is just another factory, only the roof is missing." In Sicily, at Foggia, and later in Normandy, these machines became tactical assets. A damaged runway could be rebuilt before dawn, allowing bombers to launch fresh missions by morning. The Luftwaffe, exhausted and under constant strain, couldn't match this pace. Their field units relied on manual shoveling and concrete pouring, often taking weeks to repair even minor damage. By 1944, German intelligence concluded that American engineering capacity has nullified the effect of airfield bombing. What began as logistical efficiency had become psychological warfare, proof that destruction itself could not slow an army powered by machines and method. July 1944, the Pacific island of Tinian. When the first Seabees landed, the island was a maze of coral ridges and bomb-pocked plains. Japanese forces had fortified it for years, confident that no airfield could be carved from that terrain under fire. Within 48 hours, the sound of gunfire merged with the grind of diesel engines. Bulldozers pushed coral rubble into smoking craters, while scrapers leveled hillsides that had stood untouched for centuries. Engineers worked shoulder to shoulder with Marines, clearing minefields and dragging wreckage aside to make room for runways. By the fifth day, American bombers were already using the new strip, one that Japanese observers reported as impossible to build under such conditions. The coral dust clung to everything, uniforms, weapons, and faces. Yet the men driving those machines didn't stop. One officer described it bluntly. "Our airfields were being built faster than the enemy could destroy them. They bombed by night, and by morning we were landing planes again." From Tinian and Saipan, the pattern repeated across the Pacific. Each island that fell became a launch pad for the next. Bulldozers rolled off landing ships as soon as the beaches were secured, their engines roaring before the smoke even cleared. By the time the B-29s began their long-range missions toward Japan, the engineering miracle of the Pacific was complete. 111 new airfields built across 15 islands in less than 2 years. To the Germans watching from afar through intelligence reports, it was unthinkable. Their own air bases in France and Poland required months of labor and thousands of workers. The Americans seemed to summon airfields from thin air. And soon, that same efficiency would arrive in Europe. June 1944, Normandy, France. As Allied troops fought inland from the beaches, the race behind them wasn't only for towns or bridges, it was for airfields. Without them, there would be no cover for advancing armor, no supply drops, no wounded evacuated. The Germans knew this and bombed every strip the Allies began. Yet by now, American engineers had turned reconstruction into a science. Bulldozers pushed aside wreckage from the landings, clearing the hedgerows that once protected German defenses. Within days, engineers began laying pierced steel planking (PSB) over flattened fields. The result, a temporary runway strong enough for fighters and transports. In just 72 hours after D-Day, the first Allied aircraft were landing on French soil. German reconnaissance photos taken that week show bomb scars still fresh, and beside them long metallic stripes glinting in the sun, runways reborn from chaos. The pace astonished even the Allies. What had taken months to build in peacetime was now completed in days under enemy fire. The Luftwaffe tried to counter with nightly raids, but each crater became another challenge for the bulldozers. Crews filled holes with crushed stone, rolled it flat, and laid steel matting before dawn. Pilots joked that the ground seemed to heal itself overnight. When reports of this reached Berlin, disbelief turned to despair. Luftwaffe officers noted that their bombing produces no lasting effect, concluding that the enemy's engineering power exceeds our capacity to destroy. By autumn, the Allies operated more than 200 forward airstrips across liberated France, each one a leap forward in mobility, each one built by men who fought the earth as fiercely as others fought the enemy. Germany had entered the war with the most disciplined army in the world. America was ending it with the most unstoppable machine. When the guns finally fell silent in 1945, the numbers told a quiet but staggering story. Across Europe and the Pacific, Allied engineers had built or repaired over 1,500 airfields. In some campaigns, they moved more earth than the Panama Canal project had decades earlier. The U.S. Army Corps of Engineers and the Seabees had become an invisible army of their own, 325,000 men who fought with blueprints and bulldozer blades instead of rifles. Their work gave the Allies near total air dominance. Every new runway meant shorter supply lines, faster reinforcements, and the ability to bomb or resupply anywhere on Earth. It was engineering turned into strategy, logistics as weaponry. For the men who had lived inside that machinery, the aftermath was strangely quiet. Bulldozers that once roared through shellfire were parked neatly in rows, blades rusted, engines cold. The same machines that carved the path to victory would soon be sent home to build highways, dams, and cities instead of runways. In the months that followed, the world saw bulldozers once again crossing ruined landscapes. But now they carried no insignia of war. They cleared rubble in Normandy's towns, leveled ground for refugee camps, and rebuilt the same European roads they had once crushed under treads. In Japan, Seabees and engineers turned bombed-out airstrips into cargo hubs for food and medical supplies. To many civilians, these machines became the first sign of peace. Where craters once marked destruction, new foundations appeared. The same blades that had defied enemy bombs now shaped post-war recovery. German officers who had dismissed bulldozers as industrial excess were forced to confront a new truth. That victory had not been won by brute force alone, but by the mastery of movement, coordination, and mechanical will. By 1946, reports from occupied Germany noted that American engineers were training local workers in airfield repair, drainage, and road building. The lessons learned under fire had become the blueprint for reconstruction. The bulldozer had changed not only battlefields, but civilization itself. In every great war, there are weapons that roar and weapons that endure. The machine gun, the tank, the bomber, they seize the headlines. But history often belongs to the quieter forces, the engines that move mountains, the hands that rebuild what fire destroys. The bulldozer was one of those forces. It never fired a shot, yet it broke the enemy's rhythm. It gave flight to squadrons, mobility to armies, and hope to those who watched devastation turned back into purpose. For the Germans, it was a symbol of something deeper than machinery, a reminder that industrial power, discipline, and imagination could outpace even the fiercest will to fight. And for the Americans who drove them, it became proof that progress itself could be a form of strength. By war's end, the same engines that roared through the deserts of Africa and the jungles of the Pacific were carving highways across a rebuilding world. The battlefield had changed forever, not just by what men destroyed, but by how fast they learned to build again.